Good morning, everyone. I'm a student studying in Sri Venkateswara College of Engineering, Department of Computer Science and Engineering. Today, I'll be presenting the topic Emerging Trends and Technologies in Mechanical Engineering. Emerging Trends and Technologies in Mechanical Engineering. Course outcomes explain the concepts of role of mechanical engineering and energy sources. First, we have emerging trends and technologies in energy sector. Under this topic, we have renewables, Internet of Energy, energy storage, and blockchain. Emerging trends in energy sector. Renewables. Using renewable energy helps to preserve the environment as it produces minimal to zero harmful emissions. The basic principle of using renewables is to extract it from a constant source in the environment like sun, the wind, or through geothermal sources. This includes reducing cost for manufacturing of renewables, infrastructure, and generating power with higher rates of efficiency. Internet of Energy. It is a technological term which refers to upgrading and automating of electricity, infrastructures for energy producers and manufacturers. Internet of Energy allows energy production to move forward more efficiently and cleanly with least amount of waste. Benefits of using Internet of Energy includes increased efficiencies, significant loss savings, and reduction in the wastage of energy. Energy storage. This enables stable pricing by proactively managing demand from consumers. By having the opportunity to purchase energy for future use, consumers potentially stock it up during ideal conditions. This accumulated energy later helps in reducing the grid loads during peak times. Next, we have blockchain technology, which intends to unite all energy stakeholders under a single decentralized network. Electricity producers, distribution network operators, metering operators, providers of financial services, and traders potentially benefit from utilizing smart contracts. These contracts ensure that all energy related transactions pass through a secure and immutable network, thus eliminating potential losses. Next, we have emerging trends in manufacturing sector. Under this topic, we have accessible automation. Automation in the manufacturing industry is not entirely new topic, but it's a widespread adoption of the practice is new. New technologies have made automation more accessible to more manufacturers and are changing the way of companies operate. Automation for all is the next step in the industry. Next, we have mobile robotics. It is one of the primary drivers of this manufacturing trend is a trend and while robots used to mean ultra sophisticated technology that required trained robotics, new robotics technology is making automation attainable for companies of all sizes. Next, we have Internet of Things. The Internet of Things is helping manufacturers connect and monitor the various components of their operations, gaining insight never before possible. The connectedness gives manufacturers valuable data that enables them to change, optimize, and improve every facet of the manufacturing processes. Next, we have Enterprise Resource Planning, which is also called EPR system, which helps the manufacturers automate different areas of operations under one comprehensive system. This universal touch point then gives manufacturers the insight they need to oversee the entire manufacturing operation and make improvements and adjustments wherever needed. Universal connectability. What we are calling universal connectability is that idea of technologies are now being made to connect with any device or system. Ideas getting connected to devices called universal connectability, and technologies and innovations in the manufacturing space were traditionally built as one size fits all solutions. Next, we have emerging trends and technologies in automotive sector. So, first one under this topic is autonomous vehicles, also known as self-driving vehicles. It aims to minimize the need for human drivers and looked more poised to transform everyday transportation. Fleets of AVs expand the scope of last mile deliveries, reduce downtime, and aim to make public transportation relatively safer and easier. For example, by reducing accidents caused due to driver fatigue or negligence. Next, we have electrification. The depleting fossil fuel reserves and the harm to the environment caused by their use call for promoting the use of electric vehicles. For greater adoption, EVs need to address issues such as high price, poor battery, and inadequate charging infrastructure, fleet electrification, as well as powering renewable energy based on charging grids. Next, we have shared mobility. With connected vehicles, new business models have come up that focuses on shared mobility as an alternative to traditional vehicle ownership. This enables mobility as a service and discourages unused vehicles. Such solutions meet the requirements of a city or a business without adding new vehicles, thus reducing waiting time for fleets and pollution caused by petrol or diesel vehicles. Next, we have artificial intelligence. As you all know, the name itself suggests that artificial intelligence means machine learning and deep learning and computer vision, which find applications in robotic and automation industry within the automotive industry. These guide self-driving cars, manage fleets, assist drivers to improve safety, and drive services such as vehicle inspection or insurance. Next, we have human-machine interference. As the self-driving cars and the connected trans transform the automotive landscape, it will fundamentally change how drivers interact with vehicles. As the name suggests, human and machine come together to perform this task. Such as it uses voice-based or haptic feedback to operate vehicles. These expand the scope of how and what aspects of car that uses control. Consequently, such interferences make the driving experience safer and more enjoyable. Another form of HMI, which is human-machine interference, includes smart visual assistants who help drivers and riders interact with the vehicles and other service providers. The next topic is emerging trends and technologies in aerospace sector. For under this subtopic, we have advanced materials. Innovative materials can be used in a wide variety of areas, from lighter, more agile aircraft and emerging hypersonic systems to personal protection equipment, and anywhere risks or damages can be reduced. For example, graphene is a carbon-based material which is merely 1 atom thick and can be used to make batteries that are lightweight, durable, and applicable in high-capacity energy storage, plus they charge more rapidly than a typical battery. Next, we have additive manufacturing, also known as 3D printing. This technology utilizes significantly very less materials other than comparable traditionally manufactured parts. So reducing weight is a paramount to the aerospace technology industry due to increasing performance in areas of speed, capacity, fuel consumption, emissions, and more. So this realization is leading the aerospace and defense industry to look for applications of 3D printing in its newest products, from seat frames to air ducts. Next we have supersonic flights. Supersonic flights is when an aircraft travels faster than the speed of sound. Example, the US Airlines United has announced plans to buy 15 new supersonic airlines and return supersonic speeds to aviation in the year 2029. The new Venture aircraft will be produced by the Denver-based company called Boom, which has yet to flight test a supersonic jet. Next, we have artificial intelligence. The aerospace technology industry is also benefiting from the artificial intelligence and the use of machine or active learning in research and education. Machine learning offers ability to gain new insights into materials by employing artificial intelligence to discover new patterns and relations in the data. For instance, in order to create the new generation of technology, researchers at the United States Air Force Research Lab are using machine learning. Next, we have autonomous flight systems. Implementing autonomous technologies has been a growing trend across several industries, and the aerospace industry is no exception. Much of this has been focused on increasing autonomous flights, with the end of the goal being to launch fully human free flights. While this may still be several years away, investments and innovation will consistently be geared towards this in the coming years. Moving on to the next topic, we have emerging trends and technologies in marine sector. So under this topic, we have digital route management of ships, where ships can often have journeys lasting several months and it is not feasible to accurately predict conditions in advance. So a real-time route management system has been introduced and can play a major role in improving the journey duration and efficiency in the digital route management of ships. Considering the long periods that ships remain at sea and the possibility that ocean conditions can vary drastically over the matter of few hours, it is really important to know the real-time data which is available for ship operators to use. Next, we have smart autonomous control. On land, self-driving cars use autonomous technology to make decisions based on the route they traverse. This includes detecting pedestrians, other cars, and traffic signals, as well as remaining on the road without losing control. In the shipping industry, implementing such autonomous control is a major operation, since ships are considerably larger and more complex than cars. Hence, ships should have smart autonomous control. Smart propulsion systems. With a higher degree of control comes a higher risk of damage to equipment or the vessel itself. Thus, entrusting control of the propulsion systems to smart technology enables a computer to make decisions and control the equipment with a higher level of accuracy. This allows the captain to remain in control of the vessel without having to constantly monitor the propellers. Similarly, marine engineers can allow the software to monitor the status of the marine diesel engine so that they always remain within the acceptable operating regions. Next, we have smart defense technology. Implementing smart technology in these domains would allow navies to become self-reliant and extremely efficient. For instance, during times of wars, provisions and verifying equipment to control ships, such as aircraft carriers, can be a major task. By implementing smart technology that accurately routes, deploys, and controls supply vessels would allow the logistic division of the Navy to be used in a more efficient manner. Thank you. Please like, comment, and subscribe.